Today we're going to look at section 5.6, graphs of other trig functions. Today we are specifically, though, going to be focusing on tangent. So we're going to understand the graph of y equals the tangent of x, and then look at some different variations of it when we graph. So what we want to do is we want to be looking at the unit circle, because the unit circle is going to be how we are going to figure out the shape of the tangent graph. Just like what we did with sine and cosine, we use the unit circle to help us out. Now remember, in a unit circle, these ordered pairs are always cosine first and sine second. So we have the ordered pair cosine followed by sine. But if our graph is supposed to be about tangent, we have to remember that there is a relationship between sine and cosine with tangent. If you think about that quotient identity, taking sine and dividing it by cosine will get you tangent. So it says, remembering the unit circle, we have to notice that not every tangent value is defined. I want to specifically point out up here where we have the ordered pair 0, 1, because once again, sine is the second number. If I was to take 1 and divide it by 0, that becomes undefined. Same thing down here at the bottom at 0, -1. If I wanted tangent, it would be -1 divided by 0. You can't divide by 0. That becomes undefined. So while with sine and cosine, we were able to use that whole entire unit circle. So from 0 to 2 pi, we were able to use that whole thing to create the shape of that function. We're not going to be able to do that with tangent. We're only going to be able to use half of the graph. So the half of the unit circle that we're going to use are going to be the first and the fourth quadrant. So notice that from 0 heading up, we're going to be dealing with all the positive numbers, and then heading down, even though our unit circle is dealing with positive angles, I want to be thinking about this whole entire semicircle in one fluid motion. So I can't just jump from 1 to 4 unless I think about, the fact that moving down in a clockwise position technically make those angles negative. So we've got really negative pi over 6 and negative pi over 4 and negative pi over 3 and negative pi over 2. So we want to be thinking about those angles as negative angles to keep it as, connected between the first and the fourth quadrant. So if we think about then how we created the shape of the sine and cosine graphs, we're going to do the same thing here with tangent. We're going to look at creating this ordered pairs from the tables of the unit circle. So notice that's why I have some negative values for radians, because those are the fourth quadrant. And notice that I've got some positive values because that's from the first. But at each end, at negative pi over 2 and positive pi over 2, that's where we had those undefined values because we were dividing by 0. So think about looking back at your unit circle. If I was to divide the second number in the ordered pair by the first, at negative pi over 3, it's approximately negative 1.7. At negative pi over 4, when you divide, you'll get negative 1. At negative pi over 6, you'll divide and get negative 0.6. At 0, you get 0. Moving towards those positive numbers, then when we take sine and divide it by cosine, we get positive 0.6. Divide then at pi over 4, we get 1. At pi over 3, we get 1.7. So with understanding that, those undefined values create then vertical asymptotes. So notice that we're going to start and end each of our tangent period with a vertical asymptote. 0, 0 is a critical point there in the middle, and then we'll have two other points that help form the shape of our tangent graph, which notice that inside the absolute value, or not absolute values, the vertical asymptote, it kind of looks like a quadratic. Okay, so that's the basic shape and look of a tangent graph. So here is then some information regarding our tangent function. So if we just think about y equals a times the tangent of bx, Because if I go back to that last picture, remember we're going up in one side and we're going down in another. There's arrows on either side. So the graph just keeps extending on the left and on the right. Amplitude represents height. Because the arrows point up and down, that means that it just keeps going and going and going. So you can't measure height of something that just continues infinitely. So there is no amplitude. Now remember, you can still identify A. A just helped you calculate amplitude for sine and cosine, but we don't need that calculation here when we're talking about tangent. Notice that my period is calculated a little bit differently as well, because like I mentioned, when we were talking sine and cosine, we were able to use the whole unit circle, so that was 2 pi. Here in a tangent function, because we have those undefined terms, we are only using half of the unit circle. So that's why our formula is pi divided by the absolute value b. Once again, we're going to start and end each of our periods with a vertical asymptote, and then we will have 5 critical values that are going to be important to identify to help us with the graph. So notice how whatever the period is, we're going to cut it in half to get either side of our vertical asymptotes. That's why it says undefined for the rest of the ordered pair. And then 0, 0's in the middle. So then what's halfway between 0 and a half, or halfway between 0 and negative a half? Well, those would be the quarters. So that's why we'll take negative a fourth of the period and positive fourth of a period. And then notice that A is still going to play a role in getting these critical values. So we'll only be plotting 3 points because the other 2 will be vertical asymptotes. But that's how we're going to form the graph. So let's take a look at this example. I want us to graph 2 periods of y equals 4 times the tangent of x. So just like our other problems with sine and cosine, we do want to identify a and b. That's going to be important. A is the number that's in front of our trig function, so 4. B is the number that's in front of x, so 1. Once again, there's no amplitude to identify, but we do have a period. We're taking pi, because it's half of the circle, and dividing by the absolute value of b. Well, the absolute value of 1 is 1, and pi divided by 1 is pi. So now that I have the period and I know what my value for A is, that's all we need to start finding our critical points. So remember, we want to take negative 1/2 of the period. So negative 1/2 of pi would be negative pi over 2, and that's where we have that vertical asymptote, so we're undefined. The second point would be then negative a fourth of the period. So negative a fourth of pi is negative pi over 4. And then I want the opposite of A. Since A is positive 4, I need to make that 4 negative. The middle critical point will always start off as 0, 0. And now we're moving to the right side of that axis. So now it's a fourth of that period. So it's positive pi over 4. And then I want the value for A, so 4. And then finally, we want half of the period. So half of pi would be pi over 2, and that's where we're back to being undefined. Now, really quick, notice that even though that first term, that negative pi over 2 for my first critical point, if you ignore the negative for a second, just think about the distance from 0 to the left is pi over 2. The very last one here is also pi over 2. If you add those two values together, think of them both as being positive, you should have them add up to the period. If they don't add up to the period, then you made a mistake somewhere. But pi over 2 and pi over 2 do add up to give us that full period of pi. So now let's graph. Remember, when you are labeling your axes, it's not that hard in this case to label the y-axis. I'm just going to make every tick mark go up and down by 1. So I'm just going to clearly label every couple of them so I know exactly what my scale is. It's always the x-axis that seems to maybe cause a little bit of issues. So let's go through this. So I'm just going to place every tick mark as every other. I need it both on the left and the right because I'm dealing with some negative values. Look at your denominators. We got a denominator of 2 and a denominator of 4. go with the biggest denominator. So I want to go with the 4. I'm going to go up and down every single tick mark on the x-axis by pi over 4. So that's why this one on the left is negative pi over 4. Go over again, and that's negative 2 pi over 4. It just happens to simplify that down to negative pi over 2. Then the third one over here on the left is negative 3 pi over 4. And I could keep going. But now I'm going to do the same thing on the right. So the first tick mark is positive pi over 4. Then the next one is 2 pi over 4, which simplifies to pi over 2. Then we have 3 pi over 4. Then 4 pi over 4, which simplifies to pi. 5 pi over 4. 6 pi over 4 is going to simplify to 3 pi over 2. 7 pi over 4. I could keep going and keep going. Okay, I do need to, once again, understand that this time I want 2 periods. So my critical points is going to get me 1 period, and then we will repeat that again to get the second period. So at negative pi over 2, I want a vertical line because that is my vertical asymptote. Then at negative pi over 4, we want to go down to negative 4. At 0, we're at 0. Pi over 4, we're up at positive 4. And then at pi over 2, we have another vertical asymptote. So then now we just want to try our best with those 3 points that we're trying to connect. We want it to kind of look like there's a curve to it. So I know it's a little bit hard at times depending on the distance of my A, but make it look like not a straight line, but there's a curve to it. It's getting closer to the vertical asymptotes on either side. There's my first period. Now, I've got that vertical asymptote on the right. That becomes now the new vertical asymptote for the second period. So there's the vertical asymptote. That means at 3 pi over 4, I'm back down at negative 4. Then the middle point at pi, I would be at 0. At 5 pi over 4, I'm up at positive 4. The next tick mark is 3 pi over 2. That's where I have my next vertical asymptote. So once again, just carefully try to connect those points as best you can to make it look not like a line. And there is my 2 periods of that tangent graph. Let's take a look at another example. We're going to graph 2 periods of y equals negative tangent of x over 2. So once again, let's identify our a and our b value. A is the number in front, so that would be negative 1. Because it's x divided by 2, it is technically a fraction. Your b value is a half. So sometimes you might see it written as like negative tangent of 1/2 x. Those two things are equivalent there. So remember, amplitude is not needing to be identified because there is no amplitude for tangent. But we do want to identify the period. So that would be then pi divided by the absolute value of b. So for us, absolute value of a half is a half. Because I'm dividing by a fraction, I want to multiply by its reciprocal. So it looks like 2 pi is my period. So now that I know the period and I know what my a value is, we can do our 5 critical points. So remember, we're going to start at negative 1/2 of the period. So in this case, period is 2 pi. So negative a half of 2 pi would be negative pi, and that's where we are undefined. Then I want negative a fourth of the period. So if you want, think of that as 2 pi over 1, multiply straight across and simplify down. That becomes negative pi over 2. Remember, this is where I want the opposite of a. If a is negative 1, I need that to be positive 1. Middle point is at 0, 0. And now I'm moving over to the positive of it. So positive a fourth times 2 pi would be positive pi over 2. Then I want the a value, so negative 1. And then finally, we want 1/2 of the period. So half of 2 pi is pi. And we're back to being undefined. Okay, once again, not a huge issue to be able to carefully label the y-axis. We're going up and down by 1s here. So then it's just the x-axis that we want to be very, very careful with. Okay, once again, we want to be consistent with how we are labeling our tick marks. We want to be the same distance apart each and every time. So looking at my ordered pairs, because I have a fraction with a 2 in the denominator, that's going to be what I want to go with. If there was another fraction, it'd be whatever the biggest number in your denominator is. So I'm going up and down by pi over 2. So there's negative pi over 2. The next one would be negative 2 pi over 2. So that's negative pi. Then we would have negative 3 pi over 2, and so on the left. So now we're going to repeat the same thing on the right, make it positive. Positive pi over 2. Then we have 2 pi over 2, 3 pi over 2, 4 pi over 2, would turn that into 2 pi. 5 pi over 2, 6 pi over 2 would turn that into 3 pi. 7 pi over 2, and I can keep going and going and going. Okay, so at negative pi, I want to draw my vertical asymptote. Then we have negative pi over 2, positive 1. Then we're at 0, 0. At pi over 2, we're at negative 1. And then pi, we've got our vertical asymptote. Once again, I'm going to try to make this look as curved as possible. It's getting closer and closer to the vertical asymptotes on either side. So there's one period. Repeat the process. I've got my vertical asymptote. So 3 pi over 2, I'm up at positive 1. Then 2 pi, we're back at 0. 5 pi over 2, we're at negative 1. And then at 3 pi, we have another vertical asymptote. So once again, connecting those points very carefully. There are my two periods. Notice that this graph looks backwards from what a normal tangent looks like, and that's because my a value is negative, meaning that there is a reflection happening. Okay, so let's talk about shifting. So just like when we were shifting sine and cosine, tangent is still the same as that. So if we have y equals a times the tangent of the quantity bx minus c plus d, phase shift still moves left and right, and that would be taking c and dividing by b. Remember, you always take the opposite sign for c. So whatever I have in the parentheses, change that sign to identify and help with the phase shift. Vertical shift is D, that moves up and down. You keep the sign the same. So let's take a look at this example. I want to graph two full periods of y equals tangent of the quantity x minus pi over 2. So anytime you start seeing, parentheses or anything being added or subtracted that is not attached to your trig function, that means we have to identify not only a and b, but also c and d. So if there's no number in front of the tangent, then your a value is 1. If there's no number in front of the in front of the x, then your b is 1. Because I have that negative pi over 2 in parentheses, we change the sign for the c. So it's positive pi over 2. Since nothing being added or subtracted, our d value is 0. Can't identify amplitude, there is none, but we can identify the period by taking pi divided by the absolute value of b. So absolute value of 1 is 1. I'm going to label phase shift as PS. Remember, that's C divided by B. So C is pi over 2. My B value is 1. If I divide by 1, then pi over 2 is the phase shift. Okay, so once again, there's no amplitude, and because D is 0, there's no vertical asymptote. There's no vertical shift. So that means that that's everything that I need to identify the five critical points. Okay, so I'm taking the period, which is pi. Remember, I want to multiply by negative a half. So negative a half times pi is negative pi over 2. That's where we're undefined. But then remember, I'm going to have to shift it. So that's not the final point that I'm going to plot. Then I want negative a fourth of the period. So that becomes negative pi over 4. Then I want the opposite of a, which is negative 1. Then we want 0, 0, which has to get shifted. Then I want positive pi times 1/4. So that would be pi over 4. And then I want the a value, so 1. And then I want 1/2 times the period, which is pi over 2, and that's back being undefined. All right, so remember, a phase shift, because it's positive, because remember, we're taking the sign that's opposite, I'm adding pi over 2 onto all of the x's. Because there was no vertical shift, I'm essentially adding 0. I'm not changing that second number. No matter what, if you have a vertical shift, when you add it or subtract it onto something that's undefined, it's going to stay undefined. So in the first one, negative pi over 2 plus pi over 2 is 0. But then, like I said, no matter what, adding and subtracting, you're still going to have something that's undefined. So because we have different denominators now, if you need to, think of your phase shift as a denominator of 4, which means that it's really 2 pi over 4. So I'm taking negative pi over 4 plus 2 pi over 4, which gives me a positive pi over 4. And negative 1 doesn't change since I'm adding on 0. I'm going to change 0, 0 then to pi over 2, 0 when I added those. Once again, think of pi over 2 as 2 pi over 4. If I add on a pi over 4, it gives me 3 pi over 4. Keeps that value at 1. And then pi over 2 plus pi over 2 would be pi, and we're still undefined. So those ordered pairs that I just showed you here are the points that we really want to plot. So once again, I'm going to carefully label my x and y axes. Because we have different denominators, remember, I am going to look at the bigger denominator, and that's when I want to be going up and down by. So between the 2 and the 4, I want the 4. So I really don't even have to write anything on the left because my shift ends up getting all of those x values being positive. So we're going to have a positive pi over 4, then 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, so on and so forth. I could write every single one if you want, or if you don't have enough room, that's perfectly fine. You can just space it out, but I just need to know what you're going up and down by consistently. Okay, so I know this might be a little hard to see, but because we're at 0, that means we're on the y-axis, but that's where our first vertical asymptote is. At pi over 4, we're down at negative 1. At pi over 2, which is that second tick mark, we're at 0. 3 pi over 2, we're up at 1. The next tick mark is technically pi. That's where we're back at our vertical asymptote. So once again, I'm just kind of carefully connecting those points. Needs to look kind of like a cubic. There's one period. I need to repeat that to get a second period. So at 5 pi over 4, we're back down at negative 1. The next one then would be 3 pi over 2 because it's technically 6 pi over 4. That's when we're back at 0. 7 pi over 4, we're at positive 1. And then 8 pi over 4, which is really 2 pi, we are at a vertical asymptote. So now connect those points again. There is my second period. Okay, so that's us understanding the tangent graph and some different variations of it.